Hi, are you going to class now?
Yes, I'm actually waiting for you.
Oh, okay, let's go to the class together.
Okay, let's go.
Hi.
Hey, let's go to the class with us.
Okay, let's go. Now, we are going to learn about application of differential equation. Question number 1. A metal bar with an initial temperature at 25 degrees Celsius is immersed in a container of boiling water. It was observed that the temperature of the metal bar increases 3 degrees Celsius in 1 minute. So, how to determine the time required for the metal bar to reach 85 degrees Celsius?
Equation 1 can be solved by using the Newton law of cooling or warming. It's given that dt over dt equal to k multiply of T minus Tm, where k is constant, T is initial temperature, and Tm is temperature of the surrounding medium. Since the Newton law of cooling or warming is the separable differential equation, then we get 1 over T minus Tm dt equal to k dt. Then we integrate both sides of the equation, then we get ln T minus Tm equal to kt plus c. Then we multiply both sides of the equation with the exponent. So we get T minus Tm equal to exponents to the power of kt multiply of exponent to the power of c. Since exponents to the power of c is a new constant, then we denote it as a. Then we get T minus Tm equal to a exponents to the power of kt. Next, rearrange the equation to form T equal to Tm plus a exponents to the power of kt. From the equation given, we know that 25 degrees Celsius is the initial temperature and denoted as T0 equal to 25, where T is the temperature. Then given that the metal immersed into the boiling water that we assume as 100 degrees Celsius. So here Tm, where the temperature surrounding the medium, is 100 degrees Celsius. From the information gained, substitute Tm equal to 100 and T0 equal to 25 into the equation, where T0 equal to Tm plus ae to the power of kt. So 25 equal to 100 plus ae to the power of k0. Then we get 25 equal to 100 plus ae to the power of 0. Next, we get 25 equal to 100 plus a. Then we rearrange the equation by moving a to the left hand side. So we get a equal to 25 minus 100 equal to negative 75. Therefore, we get tt equal to 100 minus 75 exponents to the power of kt.
Since the temperature increased 3 degrees Celsius in 1 minute from the initial temperature, so after 1 minute immersed, the temperature will increase to 28 degrees Celsius, which is 25 degrees Celsius the initial temperature plus 3 degrees Celsius equals to 28 degrees Celsius. Then When we insert 1 minute in the equation, we will get T1 equals to 100 minus 75 exponent power of K multiplied by 1. Then we will get 28 equals to 100 minus 75 exponent power of K. Then we rearrange the equation. We will get 75 exponent power of K equals to 100 minus 28. And then 75 exponent power of K equals to 72. After that, we will get exponent power of K equals to 72 over 75. Then multiply both sides with ln, which is we will get ln exponent power of K equals to ln 72 over 75. We will get the value of K, which is equals to negative 0.04082. Therefore, TT equals to 100 minus 75 exponent power of negative 0.04082 multiplied by T. Then, how many times taken to increase the temperature until 85 degrees Celsius? Firstly, insert 85 in the equation, which is 85 equals to 100 minus 75 exponent power of negative 0.04082 multiplied by T. Then we rearrange the position. We will get 75 exponent power of negative 0.04082 multiplied by T equals to 100 minus 85. Then we will get 75 exponent power of negative 0.04082 multiplied by T equals to 15. After that, we will get exponent power of negative 0.04082 multiplied by T equals to 15 over 75. And for both sides, we multiply by ln, which is we will get ln exponent power of negative 0.04082 multiplied by T equals to ln 15 over 75. Then we will get negative 0.04082 multiplied by T equals to ln 15 over 75. And then we will get the value of T, which is ln 15 over 75 divided by negative 0.04082. After that, we will get the value of T, which is 39.42768 minutes, and then we round off into 39.43 minutes. In conclusion, the time taken to increase the temperature of metal to 85 degrees Celsius after immersed in the boiling water is 39.43 minutes.
Question number 2. A tank contains 300 liters of fluid in which 20 grams of salt is dissolved. Brine containing 1 gram of salt per liter is pumped into the tank at a rate of 5 liters per minute. And the well-mixed solution is pumped out at the same rate. So, how to find the amount of grams of salt in the tank at time t?
Questions 2. Questions 2 is about mixing problem. Mixing problem is an application of separable differential equations that required us to create a separable differential equation based on the concentration of substance in the tank. From the questions, we are given the initial amount of salt, that is 2 gram, rate of brine 5 liter per minute, volume of fluid, that is 300 liter, concentration of salt in flow 1 gram per liter. We let A as amount of gram of salt in the tank at any time, and the formula in this question is dA over dt equal to rate in minus rate out. Rate in equal to concentration of salt in inflow multiplied by input rate of brine. So rate in equal to 1 gram per liter multiplied by 5 liter per minute. Rate in equal to 5 gram per minute. So for the rate out is equal to concentration of salt in outflow multiplied by output rate of brine. So for the rate out is equal to A in bracket T over 300 liter multiplied by 5 liter per minute. So the rate out is equal to A in bracket T over 60 minutes. Step 1. Substitute rate in and rate out into the equation. So dA over dt equal to 5 gram per minute minus A in bracket T over 16 minutes. So dA over dt equal to 5 minus A in bracket T over 60. For the step 2, we need to arrange linear differential equation. So we need to put the same variables into the left hand side. So dA over dt plus A in bracket T over 60 equal to 5. That is for equation 1. Step 3. Identify PT and find integrating factor Vt. So from the equation we get the PT equal to 1 over 60. So Vt equal to exponent to the power of integrating PT dt. So Vt equal to exponent to the power of integrating 1 over 16 dt. So you can get the answer for Vt equal to exponent to the power of t over 60.
Next, step 4, we multiply each of the term in equation 1 in both right and left hand side by Vx, which is exponent e to the power of t over 60, and we are forming a new equation 2. Then we derive the product of Vx and a in equation 2, and we get derivative of exponent e to the power of t over 60 times a with respect to t, which is equal to 5 times e to the power of t over 60. Now this is our new equation 3. Step 6. We integrate both sides of equation 3. The left hand side gives us exponent e to the power of t over 60 times a, while the right hand side here, the constant 5 can be put outside and continue to integrate exponent e to the power of t over 60 dt. Then we proceed the right hand side calculation as shown here, where we use a substitution method. We let u equal to t over 60 and differentiate u with respect to t. Then we substitute them into the original equation and solve it, and we get the answer here, which is 60 times exponent e to the power of t over 60 plus c. The right hand side isn't finished yet. Now we multiply it with 5, the constant we left out earlier. Next, we remove the exponent e to the power of t over 60 on the left hand side by dividing both sides with exponent e to the power of t over 60. Then we solve and simplify both sides, and we get a equal to 300 plus c times e to the power of negative t over 60. Now, let's find the amount of salt in the tank at time t by looking for the value of c first. So, this is how. It was mentioned in the question earlier that the initial amount of salt in the tank was 20 grams before the brine was pumped in. We have the equation. The function a is equal to 20 when t is 0. So now we plug in 20 replacing the function a. So 20 equal to 300 plus c times exponent e to the power of negative 0 over 60. Exponent e to the power of 0 is equal to 1. So now we can calculate c. We have negative 280. Finally, our problem is solved. Now we can find the amount of salt at t time by using this equation, which is 300 minus 280 times negative exponent e to the power of negative t over 60. Good luck!